In this diagram, I've got a very crudely drawn bell siphon, and the blue arrows on the outside indicate that water will be coming in from the outside of the bell from the vessel that we're trying to siphon the fluid or water in this case out from. So the lower the holes are there to the bottom of the vessel that we're trying to drain, then obviously the water level should go lower when the siphon is initiated. As the water level in the vessel comes up, it will displace the air inside the bell and then eventually spilling over into the downpipe. Considerations here for designing one of these would be to make sure that the number of square inches through the inlet holes at the bottom and passing around the outside of the downpipe are roughly equal to or greater than the number of square inches that are provided by the downpipe, so that we don't starve it for water or whatever liquid it is that we're trying to siphon once the siphon has been initiated. In this design that I've drawn here, and what I intend to use it for, is I'm going to fill periodically and then I'm going to stop filling. So once the siphon is initiated, I'm going to shut off the fill. I'm going to do that with a timer. If you have it in a constant recirculating system, it gets a lot more complicated to try to balance the inflow and the outflow such that it cycles, and that's where you'll see videos showing complicated ways of trying to make them break a siphon or do not run all the time. Well, they're in a constant recirculating system. This is periodic. So this is fairly basic. Like I said, make sure there's enough room inside to meet that downpipe. Then this is going to be a crude animation of what's going to occur, although there are far better illustrations elsewhere online, I'm sure. This is what I was able to come up with. The water level is going to come up. It's going to fill inside the bell and above. As long as it goes above that downpipe with a sufficient volume to then have enough fall down the downpipe to create a flow to then actually pull the remaining air out of the bell down and start the siphon. We shut the water off at this point. Now that the siphon is initiated and we're no longer adding water to it, the water level is going to drop. It's going to drop outside of the bell first, which is an airtight vessel, except for the holes at the bottom. And that's where the water is coming in. So again, those holes need to be large enough to allow this volume of water through to not starve it for flow. Once we get below the air holes on either side, or the passage holes on either side, air will be admitted into the bell, and that will break the siphon. As long as we always shut the water off, that's going to work. Coming up is going to be a picture of one of the PVC pieces that I used that is a 1¼ inch to ½ inch reducer bushing, and this is intended to take slip fit. So you just take a piece of ½ inch PVC pipe, you slip it into this female that we're looking at. The rib or ridge that we can see at the bottom where the hole gets slightly smaller down inside the center of this needs to be removed, so that we're going to pass a plastic PVC nipple through this. And as we come into subsequent photographs, you'll understand why that is necessary. So that rib needs to be removed. And once we've removed that, as you see in this photo, I used a deburring tool, the yellow handled tool to the left. I also eventually, after I got rid of most of it with that tool, I had to come in with a Dremel tool and a burr grinder and finish removing that. And then at the bottom of the photograph there, we have a ½ inch PVC nipple. It's a Schedule 80 nipple. I've forgotten what section. It's near the plumbing, but it's not exactly plumbing stuff. I don't remember if it's EMT conduit stuff. I don't remember what it was. This was at an Ace Hardware, so it's not a just an incredibly well-stocked industrial supply. So this should be relatively easy to come by. And you'll see why I used a threaded nipple in a few moments. But now I can pass that smooth bore of that nipple down inside this hole all the way top to bottom and actually protrude from the bottom. And that's what we're going to see in this next photo, is that now I will have driven that nipple all the way through the bushing. This is a reducer bushing. So again, 1¼ inch. And I chose 1¼ inch because it was going to allow me enough flow for the water coming in and enough volume or passageway, or in square inches anyway, to meet or exceed the amount of square inches in the down tube in that gray PVC piece here. Another key consideration I'll touch on in a few moments in a later photograph, but right now this is where I've driven the nipple through, and the nipple is driven through such that some of the smooth wall sticks out of the bottom, and that's because I'm going to put a O-ring around here to seal this up to the inside of the vessel that I want to be siphoning from. And I also need to have enough room for not just the O-ring to not be blocking threads, but also then to allow, even after I run the tightening jam nut up on this, to hopefully leave me with enough threads that I can connect a PVC female threaded section to, which we'll talk about that a little bit in a moment. And here it is after I have taken it over to a drill press. You could try to do this without a drill press, although it'd probably be far more challenging. I used a center drill to make these little pips all the way around here. It's a hexagonal nut. Basically, this bushing is, for some reason, they form it as a nut. So it's got 6 sides. I drilled 6 holes. The center drill made it very easy for me to do it without it the bit wandering around. And then this is just a flat piece of metal that's laid underneath there to help hold this to an angle. I wanted the drill bit not to go straight in. I wanted it to go as low to the right in this photo as possible to scavenge water as far down into the vessel as possible, and then carry the water up into the air passageway inside of this bushing. And that's going to be important here in a moment, but let's finish looking at these holes. I then came back with a proper drill bit and drilled the holes out, deburred them, and got them far cleaner and neater. So they should flow water better, and they also shouldn't catch so much trash, especially if you have algae or something. In this case, I'm going to be using this for automating water in large aluminum trays, and I'm going to get various grow media, and I'm also going to get maybe some algae, and I don't want them to get clogged up. If I can help it, I may still have to put a filter around the outside of this, but anyway, that's why this is. And then this is going to be a view from the top with a nipple passed through that bushing. And this is another part of the reason why I chose, or another reason why I chose 1.25" for this bushing here, is that you'll see there's some daylight showing from the outside of the workspace in through those holes that I drilled around the perimeter of the hex formed portion of this. There's a void between the exterior wall and the interior wall in this particular fitting. It was strange because like 1.5" down to a 1/2" reducing bushing appeared to be solid, and that was going to bring the plastic solidly all the way up farther into the bushing, and that was going to make it far more difficult for me to make passageways for the water to come from near the bottom of the vessel that it's going to be placed into. I was either going to have to drill down from the top and in from the sides, or I was just going to have to drill farther up the sides. I really like to get as much water out of the vessel as possible. What the idea is that I'm going to flood the tray, and water will be absorbed into the media, and then the water will be siphoned away, and that'll give it a period of time where air is able to flow through the root system and the media to, well, oxygenate the roots. So I wanted the water level low, so having about 5/8 of an inch thick top to bottom piece of plastic was not going to be conducive, and trying to drill through all that was going to be more of a hassle than I wanted to mess with. So in the next image, and I didn't do a very good job here of documenting this, and I apologize for that. I'll try to explain through this. It'll become more clear in a video section that's going to be following this in just a few moments, actually. But what this is of course the 1.25" to 1/2" reducing bushing, and what you see down below on the work surface is actually a 1.25" PVC cap. The bushing is male. It's intended to go into a female fitting. And so if I wanted to attach a piece of 1.25" tubing to this, I would have to put a coupler on the reducing bushing, then insert the piece of pipe, and then I could put the cap on it. Well, I wanted to make this short. The goal of this project is to have a maximum flood of whichever vessel this is placed into of about 2 vertical inches. And So I didn't need a piece of pipe. By the time I put a coupler and everything else on there, it was going to add a lot of unnecessary plastic to this. That's why the nipple was chosen at the length that it was chosen, because by the time I protrude out of the bottom, as you see here, I've still got about 2 inches from this hexagonal face that we're looking at here, up to where the water will then spill over and initiate the siphon. So it gives me the 2 inches of vertical that I'm wanting to have. And I didn't need a section of pipe. I mean, I could have done a section of pipe and still used the short nipple. It was just unnecessary. So this bushing, being male, fits nicely into the female 1.25" cap. It's not quite a perfect airtight seal, and obviously I'm going to glue it at some point in time, but for testing, and I'll go over that in a minute with a video, which actually I'll just go ahead and roll that clip right now. And okay, so here is the bell siphon that I've cobbled together, and it's installed in the bottom of this bucket with a nasty cut over there. I didn't want to poke a hole in an otherwise perfectly good bucket. There it is down the bottom. O-ring is underneath the hex portion there, though. There are the holes. I used a little bit of Teflon thread sealing tape on the slip fit there, because this is not glued yet. This is just testing. So I didn't want to glue it until I was kind of sure it was going to work. So it was not quite as tight a fit as I'd like. So I put a little bit of Teflon tape around there just to heal that up. And then protruding out of the bottom of the bucket, I used an EMT lock ring. They have 1/2" EMT, 3/4, 1 inch, and so forth. Well, the 1/2" EMT is using 1/2" NPT threads. So that's a 1/2" EMT lock ring holding that nipple sticking out of the bottom of the bucket there. I'll go over here and I'll flood this with a hose and see if this works. And I'll obviously have to lay it on quite an angle to keep the water from pouring out of that thing. We'll find out in just a moment. Okay. And the siphon has initiated. And this would probably work better if if I wasn't using Teflon tape, if I'd actually glued those two pieces together. But for testing, I just wanted to slip them together. And there, it broke siphon right there. It got to one of the holes. Obviously, if this was on a level surface, it would pull the water down uniformly instead of just in the corner like this. But that's about as deep as it's going to get, or shallow as it's going to get, I guess I should say. It's not going to pull it down a whole lot further because of how far up from the bottom those holes are. But in any case, there, for about $6 worth of PVC pieces, very quick and easy to put together the bell siphon. And I've got aluminum troughs, actually aluminum sheets that I'm going to turn into troughs, very big trays that I'll be putting plants in, and then I'll set up a timer to automatically flood them to above the siphoning level and then shut off and allow it to drain so that I can water them automatically every day or every other day, depending upon what the needs of the plants are. Anyway, pretty quick and easy to put that together.